Look at this massive, ancient library. Think of a traditional AI model as an incredibly intelligent student who has rapidly absorbed all these books, locking vast amounts of historical knowledge into a dense, glowing central brain. The catch is that when it is time to take the test, the exam is strictly closed book. The student cannot open any new references or check any notes. Let's see what happens when we ask this closed book system a real-world question. We'll ask, what are the latest admission rules of a university? This timeline diagram shows exactly where the problem lies. The AI's memory hits a hard wall right here, at its training cutoff date. Because the university updated its rules recently, those new documents sit entirely out of reach to the right of the barrier, leaving the system to confidently deliver an outdated answer. Watch what the system attempts to do next. It tries to bridge the gap using only what it remembers. When that pathway bounces off the barrier, the AI pieces together fragments of old data, generating an answer that is factually wrong. The major risk here is blind confidence. The AI does not have a built-in mechanism to know that its information has expired. The engineering challenge is figuring out how to let the model actively verify current facts. Rebuilding or retraining a massive neural network every single day is too expensive and too slow to be practical. A brilliant neural network becomes a liability if its facts are permanently trapped in the past. We need a different approach to how the system answers questions. The solution is a structural technique called Retrieval Augmented Generation, or RAG. Instead of forcing our incredibly smart student to rely purely on memory, we change the rules of the test. It is now an open book exam. This shift takes us from a system relying solely on fixed training data to one actively browsing a live library of current documents. Let's run that exact same prompt, asking for the latest university admission rules, through a RAG-enabled architecture to see the difference. The system does not guess immediately. It turns the AI from a passive memorizer into an active researcher. In this flowchart, notice how the user prompt doesn't go straight to the AI engine. The system intentionally intercepts the question and places it on a temporary hold. Instead, a new path branches out. This is the retrieval phase. The system queries external, trusted sources, like live databases, websites, and company records, to see what it can find about university admissions. It successfully locates the specific, up-to-date policy documents published by the university and pulls them back into the central pipeline. Now we enter the generation phase. The AI engine activates, processing both your original question and those fresh policy documents simultaneously to ensure the most accurate context. The final output is a newly synthesized, highly accurate response based entirely on the most recent information available. By prioritizing new evidence over its internal memory, the AI provides a response grounded in the current facts. When you apply this open book architecture across thousands of daily queries, the overall reliability of the AI increases sharply. By forcing the model to anchor its answers in verified text, you drastically reduce mistakes and prevent outdated information from reaching the user. With RAG, an AI's accuracy is no longer limited by the date it was built. It is determined by the quality of the documents you allow it to search. Look at how this network is snapping into alignment with these structured folders. This represents exactly how organizations apply the technology in the real world to build their own custom assistants. Rather than letting the system search the open internet, a business will direct the RAG pipeline to retrieve information strictly from private company handbooks, servers, and proprietary databases. This transforms a generic AI tool into a deeply informed, specialized digital assistant that can answer questions about internal company rules safely and accurately. Retrieval Augmented Generation successfully bridges the gap between massive AI intelligence and real-time, real-world data, making AI a reliable tool for the present.